All right, thanks everyone for coming. First off, my name's Bob Lee, and I'll be introducing you to your speakers today. Before we get started, I just want to remind you at the end of the session, if you'd share your thoughts and give us some feedback, we'd really appreciate it. I created Juice about 3 years ago, and we open sourced it 2 years ago, and it went on to win a Jolt Award. And just last week, we introduced Juice 2. And nowadays at Google, pretty much just about every Java application also happens to be a Juice application. And we found that they're a lot smaller and a lot more maintainable for it. So our first speaker is Donji. And Donji has been working on Juice since before he even came to Google. And he's responsible for kind of our more enterprise layer. You know, it integrates Juice with servlets and whatnot. And Donji's also written a book on dependency injection, which is heavily focused on Juice, and I sure hope he'll plug it in the talk. And Donji also works on Google Wave, which you guys learned about this morning, and which also happens to be a Juice user. Next, we have Jesse Wilson. Jesse Wilson's kind of the Juice star. He is responsible for He's responsible for most of the development on Juice 2, and he did an incredible job. Thanks.
Cool. All right. You've already got our names. So I guess we should get started. So we'll start out by just saying, what are you expecting to get by sitting with us for the next hour? Juice is all about dependency injection, and that is the Hollywood principle. You know, don't call us, we'll call you. So if you take that principle and apply it to your Java classes, Juice is sort of what comes out of it. It's dependency injection, invented by Martin Fowler. And we'll just talk about how Juice works and what you will, by applying Juice to your application, you'll get more reusable code, more modular code, more testable code, and you'll actually write less code to do this. So, do you want to do that?
Okay, so our talk is split up into 3 parts: the motivation, using Juice, and leveraging Juice. So most of this is going to be introductory. We're going to talk about why we think you need dependency injection or what the drawbacks are of not using dependency injection. Most applications, sadly, even today, don't make use of dependency injection, and by that, I mean the design pattern, not necessarily Juice or any of the other frameworks that are out there. So it's important to understand where we're coming from when we say Juice makes your lives easier, by first looking at how your lives are currently difficult. And then we're going to talk about the API itself, what add-inject means, how add-inject replaces your factory code, and then finally we'll take a look at the ecosystem, and we'll spend some time looking at all the extensions that people have built around Juice that make your lives really easy.
Okay. Right. So we're going to write a Twitter client. Twitter is taking the world by storm, including Google. And so just to demo the code that you might write, we'll use Twitter as our example. We'll start by writing some code using the factory pattern, and we'll show all the drawbacks. And then we'll move to Juice and show what happens and how your code changes. So hopefully the code that you're looking at will be familiar. And you can see, oh, that's the code I would have written or something. And then we'll show how your code would change if you were to use dependency injection. And then if you were to use dependency injection and Juice. So here's some code you might write. This is the click handler for the post button on a Twitter client. And so the idea is that when somebody clicks post, we pull the text out of the text field, see if it's too long. If it's too long, we try to shorten it using a tiny URL shortener. And then we tweet it off, and we're using SMS as our transport to send our tweet to Twitter's servers. So you may have noticed that the code in this example actually builds its dependencies immediately. So we say new tiny URL shortener and new SMS tweeter. And this is really convenient and it's really terse, but there's a lot of problems with it. Most notably, this code doesn't lend itself to testing. We can't run this code and say, I'm going to write a test to make sure everything's working, because every time you run that test, you're actually going to end up doing an SMS. So that means that you have to have a device that has an SMS to run the code on, and you have to pay the SMS bill at the end of the month if you do that. And also, you're also sort of at the mercy of whether or not TinyURL is working today.
and it doesn't really help with testing automation.
Yeah. So tell us about factories, Sanjay.
Okay, so the traditional solution to that problem has been factories. So a factory is a third-party object. It's another class that we've written that separates the post button clicked method and the class that it contains from the actual services that it requires. So here we don't have a direct dependency, but we have an indirect dependency. So the shortener is now not necessarily a tiny URL shortener. It's just something we get from the shortener factory. And similarly for the tweeter factory. All right? Now, the factory itself is directly dependent on the SMS tweeter, for instance. So in this case, what we've done is we've taken that hard dependency that we had between the post button handler and the actual services that we want, and we've inserted one layer of abstraction in between. It helps us, but not quite. Let's see why not.
So immediately one problem is you have to actually write this factory class. And so if you have a whole bunch of classes, that means you have to write a whole bunch of factories, and this is code that slows you down. It's not very interesting. It's another thing that you have to version control and code review, and it's just more code that doesn't actually get you anywhere in writing cute Twitter clients. So as Donji alluded to, the factory adds an indirection layer between the tweet client and the SMS tweeter that is actually going to be doing the implementation for us. But unfortunately, the dependency is still there indirectly. And so what happens is when we write applications in this style, anything that you depend on, you need to compile at the same time. So you've got this compilation time dependency, and what ends up happening is you have to build your entire application anytime you want to build any part of your application. Your application isn't very modular. And so if we take this to the logical extreme, what happens is your application blows up in a firestorm of pain and dependencies because now everything depends on everything. So the other problem with the factory is it's awkward to test. So I was writing a test for our tweeter client, and I wrote this. And so I set up a mock tweeter, which lets me intercept the text that gets tweeted. Instead of sending it to SMS, I can actually just take an in-memory object and get the tweet from there. So I wrote this test.
Well, that's a good start that you have there. So you're using a special mock tweeter in your factory. So now when you call get, it's going to get the mock instance. But I'm not quite satisfied with this. Can you tell me what's wrong?
So the problem is that when I'm using this mock tweeter, my test is going to run. We're going to click the post button. We're going to get the text out of the tweet, out of the mock tweeter at the very end on this last line. But the problem is that now I've left my mock tweeter behind. I forgot to clean up after myself. Fortunately, there's an easy fix, and that is that you have to actually add code to tear down the mock tweeter at the end. So whenever you write this factory pattern, you don't even need to worry about just setting up your mocks and getting your application testable. You have to also worry about tearing everything down afterwards.
This is a lot better, but it's still not perfect.
Oh, okay. So it turns out that this still isn't sufficient to test with factories because you still need to worry about the case where if my test fails, it'll throw in the assert method, and it won't actually get to tear down my mock tweeter. So you actually need to put it in a try finally clause. This is really ugly code. You don't want to see it in your application. It adds another layer of control flow that you don't really have to think about. And we haven't even gotten to the point of setting up the tiny URL mock yet.
So do you guys see how it's not just your factories that get polluted with all this extra code in order to enable testing, but even your tests are polluted with all this extra code in order to enable testing?
Yeah. The problem is that when testing becomes this complicated, you just don't want to write any tests. And if you don't write tests, you don't have confidence in your application, and you don't get to ship Wave on time. So dependency injection by hand. And the dependency injection is sort of a technology or a design pattern that addresses this problem very elegantly. So the principle is, instead of saying, hey, shortener factory, give me a shortener, hey, tweeter factory, give me a tweeter, we pass those in. So here's the constructor for tweet client, and it actually takes a shortener and a tweeter. And now it's the caller's responsibility to decide which implementations to use. This is this Hollywood principle again. We'll call you with your dependencies. Don't ask for them. They'll just be passed in. And what's absolutely brilliant about this is that now we don't need to worry about passing in real dependencies in our, we don't have to worry about setting up a teardown in our test. And since we're passing them into the constructor of tweet client here, so I say new tweet client and I pass in the dependencies I want to use, not only do I have to not worry about tearing it down, but I also don't have to worry about forgetting something. So you may have written applications where you get your tests, you get everything compiling, you run your test, and then at runtime it fails immediately because you forgot to prepare some factory. You forgot to initialize something or get something started up. And so now your application gets this sort of gross bootstrap system where in order to actually write a test, you need to start this service, connect to the database, do this other thing, test that the SMS radio is turned on, and now we can test. Well, with dependency injection, your dependencies are obvious, and they're part of your API. But this is where dependency injection breaks down.
Okay, so what we have here is a client factory, and it does all of the work of providing the dependencies to our object, but we've just moved it one step further. Right? We had the tweeter factory and we had the shortener factory, but now we've pushed it one step further in order to make our tweet client dependency injectable. So, I mean, we've saved a little, but we've still got our factory code to write and maintain, and it still looks ugly, and there's still the same problem. It's just one step removed.
So the idea of all this dependency injection is we've broken this hard dependency from tweet client onto its tiny URL shortener and SMS tweeter. And by moving it, we only depend on the interfaces, which is just fantastic. It means we can compile and test and do all these things. But we've really just shifted the dependency over to our tweet clients and our factories. And we just had to write a lot of factories to get this done, right? There's 3 factors here. That's a lot of code that you have to write. And so we have to have something else. There's got to be something better, and that something is Juice. So with Juice, you take your factories and you replace them with a combination of injectors and modules. And so instead of writing all that imperative code to figure out how to build an SMS tweeter and an URL shortener, instead you create a module, and this maps the implementations, the interfaces to their implementations. And injector is a Juice-supplied class that basically acts as your factory. And it's a one-stop, does-everything factory for your application, and it does it in the dependency injection idiom.
And more importantly, it's the factory that you don't have to write and you never have to maintain.
Yeah. All right, so now we can configure our dependencies using a module. And so instead of writing that 12 lines of factory for tweeter and 12 lines of factory for shortener and 12 lines of factory for everything else, instead we have one statement, which is bind interface to implementation. And this is how you configure Juice, and that creates an injector that works the way you'd like. So the change to the client code is you add the inject annotation, and that just is a signal to Juice to say, whenever somebody wants to factory construct a tweet client, call this constructor. So
we've taken that entire factory with all of that boilerplate code and that testing code that accompanied it and shortened it to the one little @inject annotation that you see there. And that's all Juice needs in order to be able to provide this class with its dependencies. Now that's a great saving.
Yeah. Especially since it's such savings in code, you'll actually tend to do it. And we believe that when you use dependency injection, you'll write better code. You'll write better code, more testable code, more modular code. Here are the 4 lines of code that you need to bootstrap Juice. You need to create an injector with your module or your list of modules. Then you can use that injector to get an instance of something. So this is just like your factory used to do. Now you can say, hey, injector, give me a tweet client. And it's parameterized on what you want it to construct, and it's fully type safe. So if you've ever used Spring dependency injection tools, then you'll notice that it's not type safe, and you need to do a lot of casting, and you need to do a little finger crossing to make sure that what you ask the injector for is what you get. With Juice, it's fully type safe. The type that you pass in is the type it will return. And if it's not there, it'll blow up spectacularly and tell you all of the details of what went wrong. So that's the motivation for Juice. And now we're going to just dive into all of the minutia of the Juice API and explain how you use it, what the day-to-day life of Juice development is like. So why?
Okay, so we've already said that boilerplate code is messy and it's difficult to test and maintain, and it's just nothing that as a developer, you want to spend your time doing. But there are also other reasons to use Juice. Like Jesse said, there's a lot of type safety that you gain from Juice. And this is because when you tell Juice, when you give it that bind statement, that's actually a signal to Juice to go out there and look at that class and make sure that all the dependencies for that class are also available and that it's valid in a way in which it can construct it at runtime for you. And that's really useful. More often than not, you'll find that fixing one small error by hand in a factory and then recompiling, you go a bit further down the line, you find another error. But Juice does all of this type checking up front for you and gives you a long error list the first time you deploy it.
It gives you Java C style errors that you can even click on and navigate right in your code to the bind statement that didn't work. In addition, when you use Juice, this is really the real value of Juice, and this is growing as our community matures. You get scopes, which is an absolutely humongous, cool feature. You get aspect-oriented programming, which is something that you may like. It turns out to be very, very convenient in your larger enterprise-y style applications, as well as any application where you have cross-cutting concerns. And there's tight integration with a whole bunch of different APIs that you already are using, such as servlets and databases and RPC systems, etc. Oh, and
Google
if all of these technical reasons weren't enough, well, Wave uses Juice, so why aren't you, right? All right. So in a nutshell, classes have dependencies, and modules define how these dependencies are resolved. This is the whole concept, right? You have code. It has dependencies. Today you use factories. And with Juice, it's the same thing. You have dependencies. And then with Juice, you configure your dependencies and the resolution using modules. So let's investigate that module resolution, and that's called a binding.
Okay. So
I'll go. All right, so we've got a module with 4 bindings here. There are the 3 statements in the code, the bind tweet client, bind tweeter, bind string, those lines, and then the method that has the @provides annotation. And so these are 4 bindings, and we'll go into detail and explain how each of them works. All right, so.
Okay, so this is a simple bind statement. All this says is it tells Juice to look in that class and use it anytime it appears as a dependency in any other code that you have. So what you need to do in the tweet client is place an @inject annotation, like we saw just earlier, on the constructor that you want to use, and all the dependencies of that constructor will be filled in for you by Juice.
Yeah.
Okay,
so,
next slide.
Missed one. All right, so the next type of binding is called a provider method, and this is really, really handy, and it's new in Juice version 2, which we released last week. So a provider method is, whenever somebody asks me for this type, run this little bit of code in order to calculate it or to compute it or to fetch it or to construct it. So this sort of is your traditional factory method type of operation where you can create something, configure it, and then return it. And the way you do a provider method binding is somewhere in your module class, you have a method with the @provides annotation and the return type that you'd like to bind. So in this case, we say @provides shortener, which says this method is a binding for shortener. And then whenever Juice needs to inject a shortener or to find a shortener for somebody else's dependency, it will run this code. And what's really handy about provider methods is that they can have dependencies of their own. So if you want to provide a shortener and it has a dependency on some HTTP factory or something like that, you can pass that dependency in via the parameter of the method. So not only can your classes have methods, but your provider methods themselves can have dependencies because your application is effectively a big graph of this depends on that, my user interface depends on the components inside of it, etc. All right.
Okay, so this is a slightly longer form of the bind statement. And what we're saying here is bind this interface to this implementation. So Tweeter is the interface that we have. We don't know how the tweets actually go out, but SMS Tweeter does know. SMS Tweeter sends them over the short message service. So all this is saying is every place that you see Tweeter as a dependency, make sure that SMS Tweeter is provided. And the great saving here is, of course, none of the client code knows that there is an SMS Tweeter being used underneath. It just uses it when it's available at runtime.
Yeah, so 6 months down the road, if we decide that the SMS tweeter isn't optimal, or if we want to use a JSON tweeter or some other protocol, all we have to do is change this one statement and say, okay, now I'm going to bind my tweeter to my JSON tweeter or my AJAX tweeter or my XML or something like that, any transport that would be used. So what's actually happening behind the scenes here is there's two bindings. There's the binding for tweeter to SMS tweeter, and then there's a second binding, which is SMS tweeter to its own constructor. So when Juice sees this, it's actually going to create a binding for tweeter, and then it'll look at the SMS tweeter's binding. And in this case, it'll just use that class's constructor. All right. Binding annotation. So far, we've always been talking about the unit of a dependency is a type. So you can say, OK, I depend on a tweeter or a shortener, but oftentimes the type doesn't uniquely identify what you really want in your dependency. So if you say, OK, I want my database address, or I want the port I'm supposed to bind on, it's not really sufficient to say just inject a string, because there may be multiple strings, and you need to really identify, OK, I want the string that is the database address, or the string that is, or the integer that is the port number. And so Juice uses a type-safe way to identify bindings in addition to the bindings type itself. And these are called binding annotations. And so you can annotate a parameter with an annotation that you define that identifies which instance of that type you want. So in this case, I'm binding the string Jesse annotated with username. And this is, again, indirect. So we can say, OK, I want a annotation called port number or an annotation called database address. So you can use Juice to configure not only your class dependencies, but also all of your configuration dependencies. So you don't have to worry about having these separate mechanisms for how you connect to your database, how you connect to remote services. You can use Juice to configure everything. And this is the standard boilerplate you need to define username annotation. I'm not going to go too much into detail on it, but this is just every time you want to define a custom name for something, use this boilerplate. You're saying about his and hers?
Oh, yeah. So the great thing about this is it does look like a little bit of boilerplate, but the awesome saving is it's purely a bit of metadata, right? You can reuse it across your application for several purposes. Like you might bind Jesse to the username where you use it in a login style scenario, but you might bind something else to a username somewhere else for a different type. So it's completely flexible, and it doesn't force you to bind directly to the actual implementation that's underneath. So in the tweeter case, you might bind it to current transport or paid transport, and really that paid transport is an SMS transport, but you can reuse the paid annotation to bind, say, a credit card transport or a credit card service, or any number of other dependencies.
And one really nice thing about the way Juice does dependency injection is that this annotation is compiled into your code. So this is just standard Java code, and if you spell username wrong, the compiler will tell you, or more likely if you're using an IDE like IntelliJ or Eclipse, it'll highlight it in red and make sure you spell everything properly. All right, so the last type of binding we're going to talk about is an instance binding, and we already sort of saw this with the Jesse example, where you can give an actual value that you want to bind to. So if in this case, instead of hard coding 8080 as a public static constant in 10,000 classes, you can configure it once in your module, and then everywhere that you need that constant, you just inject it. And this really overcomes this problem where, if you decide you want to run your FTP server on port 22 instead of 21, you have to go in and change 10,000 pieces of code where that's wired. And the main problem is that when you do that type of approach, you either have the 10,000 different definitions of that, or you have some file called constants that everything else has to depend on. So this is a nice balance. All right, you talk about scopes.
Okay, so scopes are very interesting. They're really hard for me to define in one simple way. So I'll use the simplest explanation that I could think of. For me, scopes are about duration, right? You can talk about scopes as a context. For instance, an HTTP request is a scope in Juice, or an HTTP session, which is a series of requests that come in a sequence. Or you can talk about singletons, objects that live throughout the life of an application, right? That is a scope in itself. So these are short or longer durations during which any dependency injection that's performed will always receive the same instance of the dependency.
Yeah, so when you do your factory pattern, you'll often have a private static constant that is, the tweeter. And when you say, give me the tweeter, you might lazily instantiate it. And then for the rest of your application, you always get the same instance. With scopes, you can get that sort of application-wide constant without having to actually write the statics and without having to compromise your application's testability. In our cute diagram here, we have this sort of long blue line, which is the duration of the application. This is a very abstract example without a legend, so I'll describe what I'm thinking when I'm drawing this. The red bars are HTTP sessions, and the blue bars are HTTP requests. And so you can see that the scopes nest inside of each other. So you can have, your application lives for several hours or several days or several months, depending on how your uptime is. And then every session gets its own context, and then every request gets its own context. And this is the HTTP example, but you can come up with scopes for any number of different contexts that exist in your application. So we've already sort of talked about this. These are the common scopes. So the most natural one is unscoped, and that means that anytime you want a value, it will be created, you use it, and then you throw it away. The opposite is singleton, where anytime you need a value, it's created exactly once, and you always use the same one. This is great if your application is stateful and you want to do something like track the number of hits on your server since it was started, because you can just say, use a singleton, and every time somebody does something, you call increment. Request scoped is fantastic, and it says, for the duration of my HTTP request, remember this value. This is particularly handy if you're doing a several-tier application where you want to say, I don't really want to go back to the database every single time I want to remember who the current user is. You can just put that in a request-scoped object, and it remembers. And session-scoped is the same process for the HTTP session. So if you have any session data like a cache, this works very nicely for that. So that's how you apply scopes to your objects in Juice. You just annotate them with the name of the scope. We're very annotation happy in Juice. And this is both functional, because it says, OK, there will only be one tweet client for the duration of the application. But it's also documentation. So when you're seeing this class tweet client and you're maintaining it, the singleton annotation is a really good hint that you may have to think about concurrency when you're maintaining this, because singletons are naturally need to be multi-threaded in multi-threaded applications. All right. If you want to apply a scope in a binding instead, you can also do that. So here we're saying, bind my connection pool to the executor service pool as a singleton, which is in singleton.class. Or in your provide method, you just annotate the method. And that'll mean that Juice will only call that method one time. And then it'll just remember the value. And anytime anybody wants a shortener, it just uses that same instance.
Cool, OK. So there are different kinds of injections that Juice supports. And constructor injection is the most obvious one. This is the one that we've been talking about. This is where you pass in all your dependencies via constructor, and you place an add inject annotation on the constructor to tell Juice to use it. Now, the advantage to constructor injection is really great, because you can declare your dependencies as final, which makes them immutable. Now, this is great for any concurrent class where you have multiple threads accessing the code in the same class. Then you have no danger of state leaking between these threads, because there is no state, right? You don't change the values. Yeah. It's also great for publication, which means that once the value is set, it's seen by all threads, and you never have any danger of a null pointer exception. We also have method injection, which is traditionally called setter injection. And this is almost exactly like constructor injection, but it's called after the constructors have run. And what this is just a simple setter method. So you pass in your dependency via a setter, and the method doesn't have to be called set shortener or set whatever. It can be called anything you like, so long as it has an add inject annotation. And it doesn't only have to take the one parameter. It can take as many arguments as you like, just like a constructor.
Yeah. All right. And lastly,
Lastly, we have this horrible form of injection that we don't want you to use, that we're going to talk about anyway. And this is field injection. The thing about field injection is that it's really concise, right? It's just an add inject annotation directly on the member that you depend on. You don't need to set anything. Juice will set it for you by reflection. The problem with this, and the reason we discourage it, is that it makes testing very, very difficult. Now, you have to expose your fields. In this case, we've exposed them as package local in order to access them from a test class in the same package. Now, not only is that ugly, it's also difficult for other tests that don't sit in the same package to get access to it. So we discourage this, but in a pinch or in tutorial code, it looks nice and it works.
It's very, very concise. So a lot of the intro of the talk was about removing boilerplate. And if that's why you're here, I invite you to use field injection, although you're losing out on a lot of the other benefits of dependency injection. All right, let's talk about injecting providers. So thus far, we've always been talking about, I have a dependency, you get a single instance of that dependency, and you use it. The provider interface permits something new. And the interface is very, very simple. It's parameterized on T, so you can have a provider of string, and then get will return string, or you can have a provider of shortener, and get will return shortener. So the provider's type it's a factory for a given value. So when you inject a provider into your code, and I'm using field injection here, shame on me, you can see that we don't have to actually get our shortener until we need it. So if we have somebody who's very terse and doesn't ever write tweets that are that are longer than 140 characters, we can avoid the cost of constructing our shortener until we actually need it. So in this case, we say, if text length is greater than 140, then go ahead and ask the shortener provider for a value. We'll use it, and then we'll let it go out of scope. So there's a bunch of reasons why you would use providers. First is to load lazily, which is what we just saw. So we don't actually have to worry about constructing the shortener until it's actually needed. It's also useful if you want to get multiple instances of a value. So if you need multiple database connections, instead of injecting a database connection in your constructor, you can inject a provider of the database connection. And then you can call get once for each thread that you want to use to connect, or once for each query that you need to run. Finally, providers let you mix scopes. And so this is where you have a singleton object that's sort of the overseer of everything. But it kind of wants to know who's asking, who the current user is, or what their session contains. And so you can inject a provider of user or a provider of session, and then use that to look inside. All right, so thus far we've talked about a lot of the mechanics of using Juice. Now it's time to get into the real exciting stuff, which is how do we really start to take advantage of Juice, and how does this really change our applications? We've removed the boilerplate, we've become testable, but now let's really start to figure out how you can build absolutely fantastic applications with Juice. All right, so this is a fairly abstract diagram of fairly abstract, imagine that this is Google AdWords, okay? So these are all of the classes in Google AdWords, and we are in sort of dependency nightmare mode here, where we can't compile a single module without having to build the whole world. Everything depends on everything. And it's really hard to figure out, how do I isolate this one component so that I can reuse it in AdSense, or so that I can reuse it in some other system? So you want to avoid creating this really complex spaghetti dependency application. So with Juice, the idea is that you are encouraged to divide your application up into modules. So in this case, we have 5 modules, and they all communicate with each other via the public API. And this is possible with factories, and it's possible with really good software engineering discipline. But when you're using dependency injection, and Juice in particular, it becomes very easy to have this type of discipline where you're saying, okay, only my API is exposed. And the reason that this is possible is because Juice lets you hide your implementation details. So only your module knows about your implementation classes, and then your interfaces and your domain classes and all that can be in your public API. All right, so did you see that cool transition? All right, so here's where we're at. We've written this application, and we want to swap out this entire component in the top right with a new component. And when you use dependency injection, it's about writing modular code. And modular code really means that I can swap out this blue one for a yellow one. And that can be a completely different implementation written by a completely different team. This is extremely powerful. You're writing these really, really big applications. Things get slow, things get complicated, and you want to say, rewrite. Well, Juice helps you avoid the rewrite and all of the cost with it, because you don't have to rewrite the whole thing. You can just rewrite this module, the particularly painful one. So that's really handy. But the other thing is that not only can you take an entire module, airlift it, and put in a different implementation, you can also take that module and reuse it in a completely different application. So we can take our yellow module from AdWords and then go and use it exactly the same in AdSense. And this is extremely powerful. And this is the type of reuse that was sort of promised to us with object-oriented programming, but hasn't really been within reach. You write the customer class in every single application because you don't have a customer module. And this sort of permits sort of your service-oriented application where you can actually have a module that says, these are all the APIs to talk to my service.
Okay, so Wave is famously a GWT application. GWT is Google Web Toolkit. And for Wave, we don't use this in particular, but GWT does support Juice-like behavior using a library called Gin. Gin was written by one of our Googlers, and it provides very similar functionality to Juice. When GWT is running in Java mode, or hosted mode as they like to call it, it will defer to Juice to do all of the dependency injection. And when it's compiled into JavaScript, Gin will provide the intermediary JavaScript code to do the dependency injection just like it would work in Java. Now, it does everything without any runtime cost whatsoever because the source code that's generated by Gin is exactly the same source code you would write in JavaScript to wire up all those objects with one another. So that's fantastic. The other great thing is it's the same API you use for Juice. So if you have a module that you use in a server environment and you would like to port it to the GWT environment, something that would have been unheard of before GWT and before Juice, you can do this today. It is a reality. Things like GWT RPC, where you share code between the client and the server, really becomes possible now that you have Gin sitting in this dual-use mode. Okay, so the other cool thing about Juice is, and particularly Juice 2, is the Juice Servlet extension. Now, the Juice Servlet extension is available in Trunk. You can check it out, and there's a separate jar that you need to download it and use it.
Yeah, it's a separate jar, but it comes with Juice.
It comes with Juice.
Yep.
And it gives you the request and session HTTP scopes that we saw just earlier, just out as an annotation, just like at Singleton was, that you get out of the box with Juice. Now, these are really cool, but the Servlet module has a lot more to it. As you see here, you extend Servlet module rather than abstract module when you're creating your Juice module. And what this gives you is a whole extension to the binding language to configure servlets and filters. Now, if you guys have ever used WebXML in a HTTP server like Tomcat or Jetty, you find yourself writing a lot of declarative XML rules to tell you how to route requests based on their URLs. Now, you can do all of that with idiomatic Java, just like you're used to with, with bindings and how Jetty would work under the covers without all this XML in the middle. Now, that's great because we're Java programmers and we like to write Java, but it's also great because it's type safe. I can't serve a particular URL with something that's not a servlet. So you have all these minor little enforcements that come into play that give you this extra level of confidence.
Yeah.
Now, the other great thing about the servlet module is that it has a lot more extensions than just this. It allows you to match URIs based on regular expressions. It allows you to bind keys, so you can have multiple servlets that are matched in a dispatch order. All the power of WebXML and a lot more, and none of the pain.
Yeah, the part that Donji was talking about me about earlier is that when you move your servlet configuration out of the XML file and into modules, you get a modular design for your servlets. And so what that lets you do is you can actually create a pre-packaged module for some aspect of your application, like authentication or your admin servlet, and you can say, okay, we've written the single sign-on servlet package, and we use that module in a whole bunch of different applications, and you don't have to worry about configuring WebXML for each. So if you're the single sign-on team or the security team and you have your own servlet filters and your own servlets, you can give this to your entire development staff at your company and say, okay, use this module in your servlet application, and you'll automatically get our filters and our servlets applied, and there's no other integration work. Whereas the alternative is you have to actually go in and edit the WebXML for each, and that means that you're sort of discouraged from changing your filters over time as your business needs change.
The other great thing is we do this in Google Wave, by the way. So we use this modular design. So we have particular servers that sit on the front end, and the single sign-on is the same code that's used all over Google, and we bring that into Google Wave this way. And this morning's demo, when you saw Lars doing all those fancy, cool things with the collaborative editing stuff, every single character that he typed went through a Juice Servlet dispatch rule.
Yeah.
So is it fast?
Yeah, it's way fast.
Okay.
All right, so one of the features that I hinted at earlier is aspect-oriented programming, and this is a very, very powerful, very, very complex domain, and Juice gives you sort of the sweet spot of what you want, which is method interceptors. So suppose you're writing a database thing, and you're writing this boilerplate where you need to set up and tear down a transaction for every method call. So traditionally, what you'll do is you'll say database connection.open, try, then do your actual work. And then you'll have a catch clause and a finally clause and some teardowns and rollbacks to handle the cases where your business logic either failed or there was an optimistic problem with your commit. So with aspect-oriented programming, instead of doing all of that stuff all over the place, you separate the cross-cutting concerns into interceptors, and they run around your method. So in this case, we've annotated database tweet storage with @transactional. And what this will do is it'll make sure that before and after save tweet is called, we set up a transaction, and then we make sure to commit it or roll back depending on how that method completed. Do you want to talk more about this?
Well, this is another extension to Juice that's not available in the Juice code project, but you can find it in our documentation. It's a very, very convenient thing for people who use Hibernate or the Java Persistence API, which is the foundation of Google App Engine's persistence framework. Yeah. So this is a bit of boilerplate code, very much like the factories, but something that sits in every method that does any work with the database session, and it can all be abstracted away with this one single annotation. And Juice enables us to do this.
Yeah. The other thing is that this AOP, it really fits hand in glove for transactions. And there's a handful of other cases where it also fits very nicely. So on my former project in billing, we used AOP and Juice to do security. And so you'd have a method that says, make payment, and we would have an annotation on that method that said, @secure. And that would require that whoever was calling that method had a prior login. And you can annotate your methods and configure all of this stuff just exactly as you need it to fit your application. So you can define your own annotations, and you can define how those annotations behave. It's fully pluggable, and in its core, Juice knows nothing about transactions. It knows nothing about servlets. It knows nothing about security. But it supports all these things to be added on with its own modular architecture. All right, so the last part is that Juice is fairly open to extension and manipulation. So we've talked about binding so far, and we've talked about injections. All of this information, all this metadata about your application is exposed through Juice's introspection service provider interface. And so when you define your module and you set everything up, Juice will actually give you all of the metadata that it has internally so that you can take that and analyze your application. The most interesting one so far has been that we've been graphing our applications. You find really interesting things when you can take your entire 10,000 class application and spit it out into a graph and say, you know what? That dependency there, that one's broken. We need to fix that. And you can't do that type of thing by just inspecting the code, reading line by line, because the modules are, modular. One's over here, one's over here. the introspection API lets you see it all at the same time. It's also used internally by Juice to do some of the more testy, easy configuration types things. So when you have a module and you say, okay, I want 90% of this module, but instead of that binding to the production database, I'd rather bind to the QA environment database or the Canary database. So you can take that module, override it with just the stuff that you want, and you can create a new module. And this all uses the introspection SPI. It's sort of built on top of Juice's own APIs. All right, so wrapping up. Dependency injection leads to testable, reusable, modular, maintainable code. And we love dependency injection, but you really want a framework. And Juice makes dependency injection easy. It's very concise. You add that annotation. Very little boilerplate that you have to write. And once you've got Juice and dependency injection in play, then there's a whole new avenue of components and modules that you can use as well. So this is your scopes, your AOP, your Warp Persist, your App Engine integration, your Google Web Toolkit integration. And Juice is also really lightweight. So we're serious about this, and we don't think that it makes sense to include a sort of large kernel in applications. So although Juice drives some of the bigger applications at Google, it also works on Android. It's a fairly lightweight, simple library. And then it's got a sort of pluggable thing, so you can put the servlets for App Engine or the UI stuff for Android, and it all just sort of works seamlessly. All right, and the book plug.
Yep, so I've got a book coming out called Dependency Injection. It's mostly a design patterns book, but it has a lot of focus on Juice and another framework, Spring. And if you use that discount code and go to that URL, I believe you get a 40% discount for 1 week.
Yeah, Google I/O only. So you can get the book in Manning Early Access right away.
Yep, and then once it's ready, it'll be shipped out to you.
Yeah, the book really goes into full detail about all of the stuff that we've just breezed through in the last hour. And I guess now we should open the poll up for questions. We're using Google Moderator. So if you guys have your laptops handy and the Wi-Fi is working well, you can post questions there. Otherwise, please use the microphones here. Thank you. Cool. All right. Question?
How do I compose modules?
How do you compose modules?
Take several small modules and build a big module.
Yeah, so the module API actually has a method where one module can install another module. So you can say, okay, here's my entire front-end module, and then you may have multiple teams. You've got your team in New York working on the billing system, and your team in LA working on the user authentication system, and a team in Mountain View working on the features. Your front-end module can just install each of those. And what's really nice about that approach is that those modules are independently reusable. So those teams can work independently of one another, as well as when you actually need to go out in production and you need the whole team's code all in one binary, you just compose it all into one system. Now, if you have multiple bindings for the same type, so if Donji binds his tweeter to SMS tweeter, and I bind it to JSON tweeter, Juice will detect that at startup time when you call that juice.createInjector method, and it'll say, these are all the following bindings that we had problems with. And this one happened on line 45 of SMS module, and this one happened on line 32 of JSON module. And it'll help you to resolve that.
There's also a really simple way to compose modules, and that is when you're bootstrapping Juice, you just give it a list of modules. And it's just a simple Java util list. Give it as many modules as like, they'll be installed in order.
Yeah. So we got a question from moderator that Jesse in Mountain View wrote. What apps use Google Juice? So the ones at Google that use it are, we started out with AdWords. We had this really big application, fairly hard to maintain. We had a lot of factories and a lot of static state and a lot of database connections that were required for tests that had nothing to do with the database. And so Juice really rescued AdWords front end and gave it a couple more years of life by making it so that all of a sudden you could use certain components of AdWords independently, and that's breathed new life into it. There's also Gmail, Orkut, Docs, YouTube, Wave.
Pretty much every new Google application these days.
All right. Is Juice Servlet module now a superset of Warp Core? So, good question.
The answer to that is no. It has very similar functionality, but Warp Core is now defunct. So Juice Servlet takes precedence. It supersedes it.
Yeah. Warp is still useful for the database integration stuff.
Yeah, that's a separate. Warp is a bunch of modules that build on Juice.
Yeah.
And so Warp Servlet was one of them that I initially wrote as a standalone extension, which is now part of Juice.
Okay, so comment on Java SE and comparing it to OSGI. So Juice interoperates very nicely with OSGI, thanks to my friend in Sri Lanka, Stuart McCulls. And so the way that OSGI works is it's very much a sort of deployment time thing where you say, okay, I've got this class and it has this dependency on this other class, on this interface. And then the OSGI runtime boots up and figures out, okay, we actually have an implementation of that interface online, and it's fairly dynamic, and the configuration is through your manifest. Juice has a totally different approach. So OSGI is all about sort of like defining modules on a sort of compilation level. Juice is more about defining, applications. So you write your classes, you write their dependencies, and this is, it's at a slightly different level. So Juice and OSGI don't really compete with one another. The biggest thing that's cool with OSGI is that you can use it to do hot swap class loading and unloading, and that all works with Juice now. There's going to be a new module JSR that Crazy Bob, who introduced us, is working on. And that is also probably going to play very nice with Juice and the future dependency injection tools.
So standardizing, I assume the question is about that JSR. There's a joint effort between SpringSource, the creators and maintainers of Spring, the father of dependency injection frameworks, and Google. Bob Lee is leading the effort in providing a Java series of annotations and interfaces that will take over.
So when you saw the @inject annotation, you had to have a com.google import, and sometime in the Java 7 timeframe, hopefully, you'll be able to have a java.inject annotation instead, so you won't have to even download anything. And that's because this approach is really proving itself. I don't think you should wait for that. Go and get Juice now and become familiar with it, because it's really where application development is heading. All right.
Could I ask there? I believe there's other efforts too to do dependency injection that are
Yes.
Not as compatible to Juice. I don't know. Is there a plan for merging those?
Yeah. So the question was, there are other dependency injection frameworks that are incompatible with Juice. Currently, it's sort of a pain in the neck. You have to either use Juice or use something else or write your own integration layer. Juice provides built-in Spring integration, and going forward, we're going to try and get everybody else on board and cooperate. But for now, the dependency injector that you use is sort of the one you want to use for your entire application. Does Gin support method interceptors? Gin does not support method interceptors today, but if you watch the commit logs, it's something that they're working on. And what it'll do is like the rest of Gin, it'll do compile time code generation, where classes get generated via GWT's Java to JavaScript engine. All right. What's the status of JAX-RS versus Juice Servlet?
Okay, I can take this one. JAX-RS is the Java API for RESTful web services. It was originally called JAX-REST, but a certain author of REST did not like that. So JAX-RS is basically an effort to provide an out-of-the-box application framework, which is an alternative to the servlet programming model. So this is something that's not always very clear, right? The way in which you program in the standard idiom of Java web servlets is that you have this one servlet class, and you map it to a URL, and it takes care of all of the dispatching work underneath and generating the response and everything. And it's fairly geared towards web pages, so JSP and servlets kind of go hand in hand, for instance, and most web frameworks are built on top of servlet. JAX-RS, on the other hand, is completely about exchanging resources, right? It's built on the RESTful model of identifying a resource, which may be anything from a document to an image or an MP3 file. And it's purely about dispatching incoming requests to a resource processing class and handling all of the RESTful integration in between, things like security, caching, content negotiation, and so forth. Juice Servlet, as might be obvious, sits on the servlet side of things. And so the JAX-RS isn't really, it's
They're
quite orthogonal.
Complementary.
Yep.
Cool. Any more questions? Oh, there were some issues preventing the use of Google Servlet on App Engine, but I noticed some recent commits that suggest it's not working. What's the status? It works. So you can, we have a wiki page that explains exactly what you need to do to get Juice working on App Engine. And the two are really complementary. You get all of your nice Juice injectable dependencies and all of App Engine's easy deployment, no infrastructure, anything like that. Question from the audience?
What's involved in converting an existing Spring application to Juice, either partially or completely?
So the question is, what's involved in converting an existing Spring app to Juice? So Donju, you should probably talk about this because you know more about Spring.
Okay, so that's a great question. Jesse mentioned earlier that we have a Spring integration extension. So it's just like Juice Servlet. It's called Juice Spring, and it's a simple little module that scans your Spring Bean Factory, which is Spring's equivalent of our injector, and registers all of the definitions in there as Juice bindings. So you can directly start using your Spring configuration in your Juice app with absolutely no work at all. You just write this little integration library. And then you can port one by one or in groups or as is convenient to you until your entire app is moved over to Juice, which is the way I think we'd like it.
The one thing that you can't do with Juice and that the Spring folks do really well is that Juice is really an injector. It's really lightweight and small and compact and meant to be embedded, whereas Spring is an ecosystem of it's really like a competitor to Java EE. So you have an entire module for security that's built into Spring. You have big stacks for absolutely everything that you could possibly want to do in an enterprise application. So although Spring has a dependency injection kernel, the focus of Spring is really about building an enterprise development platform. So they don't, although there are alternatives, they don't really compete on the same scale. Juice is really for people who want to have simpler, mobile, GWT, less XML type of application. So, all right, I think that's it. Thank you. Thanks, Andrew.